everyone. Let's verify trig identities now. So this is pretty much the same thing that we did with simplify. The only difference now is I'm kind of giving you the answer. I'm giving you the question and the answer at the same time. So what we're trying to do is I'm going to pick one side of this equation and I'm just going to simplify that side until I get to the other side. And this might seem kind of counterintuitive, but the side that you want to pick is the side that looks more complicated. And what I mean is, if you see sine squared, you're like, that looks, hey, that's pretty simplified. I want to use that. It's like, there's not anything you can do to sine squared. Here, there's some stuff that we could maybe try and simplify. But the goal is, I'm going to simplify this side. I'm not like moving things to both sides or solving an equation. I'm just simplifying this side until I get to that answer. This is the answer. So these are algebraic proofs, essentially. So what I'm going to do is take this guy on the left, and I'm going to say, all right, secant squared minus 1. Let's do the same strategies we did yesterday, which was, first of all, let's convert everything into sine and cosine. So do this minus 1 over 1, and this is all over 1 over cosine squared theta. So what I'm doing right now is instead of secant, I'm writing 1 over cosine. 1 is just 1 over 1, and then again, secant is 1 over cosine. So I'm just writing it in terms of sine and cosine. Now what I'm going to do is look at the numerator and say I need to get a common denominator because I am subtracting. So I will give this guy a cosine squared theta in the top and the bottom. And now in the numerator, I have cosine squared theta as my denominator. And I have 1 minus cosine squared in the top. And in the bottom, I still have 1 over cosine squared theta. All right. So now, that's a sweet looking S there. Let's try and just make it a little bit. Now that I've got a fraction over a fraction, I'm going to try and copy, change, flip. So I'm going to copy this guy. I will change this to multiplication, and then I will flip it. So now it's cosine squared theta over 1. So I copy this guy, change to multiplication, and then flip it. And now we can look and say, all right, now first of all, remember, these guys are connected by subtraction, so it's all or nothing. If you can't cancel this entire factor, you can't cancel any of it. But this, you can cancel, cosine squared over cosine squared. So now we have 1 minus cosine squared theta. And this is where you need to go back to your trig identities and start with the Pythagorean identity, sine squared theta plus cosine squared theta equals 1. And you're like, can I move this? Can I move something around to get 1 minus cosine squared? And it's like, yeah, if you were to subtract cosine squared theta on both sides, you would have 1 minus cosine squared theta, and that's an identity, that is sine squared theta. Because you subtract the cosines, you get 1 minus cosine squared is sine squared theta, so that is sine squared theta. And if you remember, our whole goal was to end at sine squared theta. So hey, we did it. Okay, I'm trying to prove that this can be simplified to sine squared theta, so I just simplified and kept going until I got sine squared theta, so that's my answer. There's never a time when you do these problems where you're unsure if you're finished, because the answer is just the other side of the equation. So you know what it's supposed to come out to, you just have to kind of convince me. You gotta follow the rules, obviously. Let's try another one. Alright, so again, we're trying to end at one of these sides. You can either end on the left side or the right side, and I'm thinking, I don't know, I mean, this side looks messy. This looks worse. That's what you want to deal with. And you want to look at the side that looks harder because it gives you something you can try. So what I'm going to do is simplify this until I get to 2 times tangent times secant. And if I look, I'm like, well, I'm subtracting, so I think what I'm going to have to do is get a common denominator, which means I have to multiply the denominators times each other. Sine of x. So to do that, I'm going to take this guy, and I'm going to take this guy, and I'm going to multiply them times each other. So my new denominator will be their product, but again, if you do it in the bottom, you also have to do it in the top. So, alright. Okay, so over here, I'm multiplying the top and the bottom by 1 plus sine of x, and over here, I'm multiplying the top and the bottom by 1 minus sine of x. So I'm multiplying the denominators times each other so that my new denominator is their product. 1 plus the sine of x, 1 minus the sine of x. And now I just have to focus on the numerator at the top. Well, up here I have 1 plus the sine of x times 1, but then it's minus 1, so you need to make sure you distribute. That's a negative 1. So this will be negative 1 times 1 is negative 1, and negative 1 times positive, or I'm sorry, negative 1 times negative sine x is positive sine x. So I look at this now, and I'm going to simplify that, and I see that I can cancel out the 1's, and I have sine of x plus sine of x, which is 2 times the sine of x. And this is over the same denominator I had before, which is, there we go, there's my denominator. Now I look at this, and I'm like, oh, that's cool, I've simplified it, but I don't have 2 times tangent times secant. So, well, I guess what I'm going to have to do is, maybe I'll mess with the bottom. So 2 times the sine of x, I'm going to FOIL. And this is dots. These are conjugates. So when I multiply, I get 1. And then the outside will be negative sine x, and the inside is positive sine x. So those actually cancel out. And then you end up with sine times negative sine, which is sine squared x. So again, when you FOIL this, 1 minus sine of x plus sine of x, those cancel out, minus sine squared. These are called conjugates. If you think about dots, the middle cancels out. But I'm still not there yet, so then I look at this, I'm like, that's probably a thing, right? 1 minus sine squared is probably a thing. You come back here, you're like, I can do the same thing, and do 1 minus sine squared. That's cosine squared. So this is 2 times the sine of x over, I'm going to write this a specific way, cosine of x times cosine of x. And you're like, why are you writing it instead of cosine squared? Because I know where I'm trying to end. I'm going to go back to what I'm trying to say at the end. 2 times tangent times secant. So if you look now the way I've written it, that's tangent and that's secant. So this is 2 times tangent of x. Oh my gosh, I'll pause it. Okay, so sine of x over cosine of x is tangent x, and 1 over cosine of x is secant x. So even though we get to here, you still need to kind of recognize that you need to take apart this fraction and build tangent and secant out of that cosine squared. So you obviously need to be able to get to here, but then you also need to understand, okay, how can I rewrite cosine squared so that I can see where I'm trying to end? You know the answer at the end. So the last step in every one of these verify problems should be writing essentially the other side. I'm just trying to show me how to get there. A couple more. Again, look at which side looks more difficult. Which side has things you could try? The left side, I could probably distribute. So let's do that. Let's distribute. We'll do cosine of theta times secant of theta minus cosine times cosine is cosine squared theta. Now you might be able to just say this is 1, but I'll write it out. I know that multiplying a number times its reciprocal will always be 1. So cosine of theta times secant of theta minus cosine squared theta. And now hopefully you can see those cancel out. And you get 1 minus cosine squared theta. And then again, that's the same identity we used in the other problem. 1 minus cosine squared theta is sine squared theta, which is what we were trying to prove. So we are done. You're just going to mess with one side until you get the other side. Okay, one more. Which side looks more difficult? Probably this side. So let's say the cosine of x over 1 minus the sine of x. So for this one, I think what I need to do is take the idea that I learned in the previous problem and apply it. So I'm going to try something that you haven't maybe ever thought to try, and that is called multiply by the conjugate. So what I'm going to do is, if I ever see something like this, like 1 minus sine of x, and I'm like, man, if it was 1 minus like sine squared, if it was 1 minus sine squared or 1 minus something like that, if this was a squared term, then I would be able to do a substitution. So you kind of think that, and you're like, I wish I could do a substitution. Well, what you can do is take this idea that we learned back here, where we were multiplying these conjugates times each other, and just try and decide to start with that. So I'm going to multiply by, where'd my problem go? 1 plus the sine of x in the top and the bottom, and I'm doing this only because I know that sometimes it can help me. I'm multiplying by the conjugate. Instead of a minus, I'm going to multiply by the same two terms, but with a plus. You'll see, hopefully, that this will help us in a second. I'll distribute on the top, so I have cosine of x times 1 plus, cosine of x times 1 plus the sine of x, put in the denominator. I'm going to FOIL, so 1 times 1 is 1. And again, plus sine x minus sine x, those cancel out. And then when you do sine times sine, you get sine squared. So now I will write this as cosine of x, 1 plus sine of x, and it's over. Now that I've got it as a sine squared, I can re-substitute and make that cosine squared of x. And this is the cool thing, is now you can cancel out one of these cosines, and you have 1 plus the sine of x over cosine of x. It's like, man, we're almost there, but I'm trying to get secant plus tangent. How am I going to get secant plus tangent? This is one where if you have a single term, a monomial in the denominator, it might be beneficial to split this fraction up. 1 over the cosine of x plus sine of x. Sine of x over cosine of x. Now, understand what I'm doing here. I'm splitting this fraction apart. They have the same denominator, which is cosine x, but I took the numerator apart. 1 plus sine x. If I were to sort of put it back together, they have the same denominator. Now I just write 1 plus sine of x all over cosine x. So you can do this as long as every term has that denominator. So it has cosine in the bottom, cosine in the bottom. Cool. Now I can think, oh, wait a minute. 1 over cosine, that's secant of x. Sine over cosine, that's tangent of x. Secant plus tangent is what I was trying to get at the end. It's over there. So that one requires sort of a new strategy, and that idea is called multiplying by the conjugate. I'll write that word for you so you can see it. Conjugate. It's the same two terms, but one has a plus and one has a minus. And you use that when you want to raise the degree of something to be something squared so that you can do a substitution. So that's it for your verify notes. Make sure you go through those practice problems. Make sure you get your checkpoints done, and make sure you hit like and subscribe.